All right, so we're going to be looking at perimeter, circumference, and arc length. And circumference is really just a special case of perimeter in which we're finding the distance all the way around a circle. Okay, so in other words, we're finding the arc length all the way around the circle. And with perimeter, normally what we think about, like if I had a square, is we just add up all the sides because we're finding the distance of that boundary line along the outside of the figure. Okay, now with circles, when we're talking about circumference and arc length, we have to understand that we're only measuring that arc length, okay, the actual arc. If we want to find the perimeter of a given figure, maybe we're going to be dealing with something like this later, we have to keep in mind that when we're talking about arc length and circumference, we're only finding this distance here. We're not including distances here and here. So that's where circumference and arc length kind of differ from perimeter. Is circumference and arc length are only going to tell us the length of this curvature here. But if we want to find the actual perimeter, then we have to go back and add whatever this measurement is, plus this, to find the actual perimeter. Okay, so that's kind of where the idea might differ a little bit from between circumference and perimeter. And it says in our notes here, it says the perimeter of a circle is called its circumference. Okay, so if we have an actual circle, and we're not just talking about a sector of the circle, in other words, we're only talking about a semicircle or something like that, then we'd find the measurement all the way around, and that would be the perimeter of the circle. Okay, now the circumference of a circle is the distance around the edge of the circle. In other words, it's the arc length of the circle. Okay, kind of like what I was saying before. To discover the circumference formula, we need to look at the relationship between the diameter and the circumference. And the ratio between these two values is will reveal one of the greatest numbers of all time, pi. Okay, so there's a special relationship between the ratio of a circumference and a diameter. Okay, now before we do that, when we're talking about the circumference, just so that we're on the same page, what we're really talking about is the distance. The distance around a circle, or we could say the distance around the boundary line of a circle. Okay, the distance around the boundary line was circle. Okay, we're talking about that entire arc. Okay, now we talked about a little bit about the similarities between perimeter and circumference, but what we want to discover is this relationship between the circumference and the diameter in terms of how does that ratio tell us pi, okay? Because we have to be able to use that for our circumference equation, okay? Now, if we look at a circle, just to kind of review before some things hopefully we've seen before, in the middle of a circle is our center, okay, and the chord that goes all the way across a circle that goes through the center is the diameter, okay? So our diameter D would go all the way across our circle through the center, okay? Now the diameter, if we divide that in half, if we only look at half the diameter from here to here, then we're talking about the radius, okay? The radius of that circle from the center to the outer edge. Okay, now there's a special relationship that we can look at between the circumference and the diameter that helps us discover pi. Okay, now if I take this entire edge from point, and we go, I should probably go this way, but if we started here and we went all the way around to that point to this point, okay, and we're sort of take that circle and break it apart and lay it out and so that it's a straight line, then we'd be going from this point to this point. This would represent our circumference of that circle, okay? So if we're to kind of unpin one of these points and lay it out as a straight line, that would represent the circumference of the total distance around the circle just laid out as a straight line, okay? Now, go back to when we worked with our compasses. Maybe I should use a different color. Let's use orange. Our compasses. If I put pointy stabby end here and make an arc here to represent the length of the diameter, then I can also use that to measure out how many diameters can I fit on my circumference, okay? So pointy stabby end here, marking off, I have one diameter that fits on there. Pointy stabby end here, mark it off, 2 diameters fit on my circumference. Pointy stabby end here, marking off there, 3 diameters fit on my circumference, okay? And notice we have just a little bit left over, okay? Now we could also do the same thing for this circle. If I take the outer edge, that boundary line of our circle, let's use red. If I take the boundary line of our circle and lay it out, then this guy right here would represent the circumference of that circle. Then if I take my compass, mark off pointy stabby end here, mark it off here to represent the length of my diameter, we could also use that length in a compass to measure out how many diameters would fit on this circumference. Well, pointy stabby end here, mark it off, 1 diameter fits on there. Pointy stabby end here, mark it off, 2 diameters fit on there. Pointy stabby end here, mark it off, 3 diameters fit on there with just a little bit left over, okay? So notice we have kind of a pattern here. 3 diameters fit on our circumference with just a little bit left over, okay? So the way mathematicians can kind of think of this is we're kind of talking about this ratio between the circumference over the diameter, right? Well, when we're talking about the ratio, we're talking about a fraction, in other words, division. Division really means I'm dividing it up into equal parts. Well, in our case, if we take circumference divided by diameter, notice it breaks up into 3 diameters with just a little bit left over. So I have 3 equal parts of diameter with just a little bit left over. So since it doesn't divide evenly, they said, let's call this ratio pi, okay? So pi just represents it's like 3 with a little bit left over, okay? Well, if that's the case, if I multiply d to both sides, then my circumference is pi times diameter, okay? Now, what they discovered is this is actually our equation for circumference, and what they found out is if we take the circumference of any circle divided by the diameter of any circle, then that number pi we're referring to, that number pi, is approximately 3.14. So remember I said 3 diameters fit on it with about a little bit left over. Okay, so it's approximately 3.14. So that allows us that we now that we know kind of what it represents, we could take pi times the diameter of our circle, and that would always give us the circumference. In other words, if we're talking about the entire circle, the perimeter, that circumference of our circle. Okay. Now, that's where this guy comes from. Okay, so the circumference is pi times diameter, or if we think about it a slightly different way, 2 pi r. Well, you might say, well, Mr. Pinkstrauss, where does that come from? Remember, diameter, if we divide that in half, that gives us radius, right? Okay, so half of a diameter is radius. So if I multiply 2 to both sides, then diameter is just 2 times r, r times 2. Okay, so all they're doing here is replacing d with 2r. Okay, 2 times the radius gives me diameter. Okay, so either one of these would help us be able to find the circumference of our circle. Okay, now let's look at a couple of examples here, and then we'll do some, basically we'll do the rest of these together, but let's look at the first two here. It says, if this is my circumference, the circumference is 9 pi centimeters. Okay, so the distance around that circle is 9 pi centimeters. What is the radius? Well, this is given to us in terms of d times pi, diameter times pi. Remember, radius is half the diameter. So what we really need is 9 divided by 2 to find our radius. Well, what's 9 divided by 2? 4.5. So the radius is 4.5 centimeters. Okay? Well, what if they give us the radius? Can we determine the diameter? Yeah, it's just working backwards. Radius to get to my diameter is 2 times the radius equals diameter. Okay, so twice the radius because it's all the way across. So in our case, it's 2 times 16 equals our diameter. So 2 times 16 is 32 centimeters. Okay, well, what if they give us the radius and we want to find the circumference? Well, that's where we just use our equation, c equals 2 pi r. So in our case, we'd have 2 times pi times r, which is 3. Well, pi, we can just think of it like a variable and don't worry about it. And let's just multiply 2 times 3. So we'd have 2 times 3 is 6, so we'd have 6 pi. So my circumference in terms of being exact would be 6 pi. Now on a calculator, you can multiply that out 6 times pi, which remember is approximately 3.14, and round it to 2 decimal places. But this would be the exact answer. So the circumference is 6 pi, okay, where 6 would be the diameter. Okay, now this one says if we have c equals pi, can we tell the diameter? Remember, the equation is pi times diameter, or another way we can think of it is diameter times pi. If there's nothing written in front of pi, we have to have a diameter, okay? This is kind of like a variable. Remember when we have something like, y equals x? We always treat the number in front of x, if we don't see it, like a 1. That's the same thing here. If we don't see it, it's really 1 times pi, because 1 times pi is pi. So our diameter would be 1, okay? So even though we don't see it, it's like there's a 1 in front here. It's 1 times pi, so the diameter is pi. Or excuse me, the diameter is 1, okay? Now, with all that knowledge in mind, what we also want to find is arc length. Okay, so when we're talking about circumference, we're talking about the distance all the way around the circle. When we're talking about arc length, we're just looking at a certain portion of that circle, okay? For instance, maybe like a semicircle. Now, the problem with that is, in terms of a circle, all the way around would be 360 degrees. So if we look at an entire circle going all the way around, that would be 360 degrees, okay? So if we're looking at half of a circle, okay, if we're looking at half of a circle, maybe this is our center point. If we take a line, our radius here, and we were to move that all the way to the other end, that'd be 180 degrees. Well, it makes sense because this is a straight line, right? A straight line is how many degrees? 180 degrees, okay? So we're only looking at 180 degrees of the circle. We're only looking at half of the circle, okay? So if that's the case, we have to kind of think of it in a different manner, okay? The arc length here is really going to be the circumference of the entire circle. It's the circumference of the entire circle, but it's multiplied by, or we can try to put this in a better term, it's really half of that circumference, okay? It's half that circumference because we're looking at half the degrees. In this case, 180 degrees out of the total 360 degrees, okay? So since we're only looking at a portion of the circle, we are going to multiply 180 out of the total 360 by the circumference, and that would be this arc length here. Okay, that would give us this arc length here because we're only looking at 180 degrees out of the full 360 degrees. Or in other words, if we reduce it down, we're looking at half of the circumference, okay? Half of the length, okay? So that's kind of where this guy comes from, okay? So with that in mind, we know the diameter is 20. We know that we're only looking at 180 degrees of the circle. So we're going to take 180, and I should point this out here. They use S to represent arc length. Okay, S is used to represent arc length. We're going to take 180 out of 360, because that's the portion of the circle we're looking at, times our circumference of the full circle. Okay, so with that in mind, we'd have 180 over 360 times our circumference. Well, the circumference, if we were looking at the whole circle, would be pi times diameter, right? Well, our diameter is 20, so it'd be pi times 20, or we could think of it as 20 pi, okay? So that's where this kind of comes in down here is pi times 20 or 20 pi. Well, then what we could do is we could reduce our fraction 180 over 360. That reduces to 1/2, and then we'd have 1/2 times pi times 20. Well, 1/2 times pi times 20, we can ignore pi. What's half of 20? 10. So we'd have 10 pi, okay? So the arc length of this guy right here, this length right here, would be 10 pi. Now, in your calculator, what you could do is you could take 10 times pi, okay? A lot of times in the calculator, you'd hit 10 times, then go to the shift key or second key, depending on your calculator, hit that shift or second key, and then find the pi symbol, multiply that, and that should tell you that we get about 31.42 centimeters, okay? Now, that isn't only for a semicircle, okay? We could use it for other portions too. For instance, if we're looking at this guy, this tells us that we're only looking at this arc length here. We don't want to know the whole circle. We just want to know this length here if we know that the central angle is 90 degrees. So if we have a central angle here of 90 degrees and a radius of 11, can we find this length here? Well, yeah, it's the same idea. Instead of looking at the full 360 degrees of the circle, we're only going to be looking at 90 degrees out of the full 360. Okay, so to find our arc length here, we're going to take 90 over 360, that fractional part that we're looking at, multiplied by the circumference. Okay, well, in this case, that turns out that we're really looking at if we reduce it down, a fourth of the circle times our circumference, which makes sense. Okay, if we look at the full 360 to find the circumference, and we're only looking at 1/4 of the circle, then the arc length would be a fourth of the entire circumference. Okay, so that's kind of where this comes into play. Okay, so setting that up, we'd have our arc length is 90 over 360 times our circumference. Well, our circumference is going to be, in this case, do they give us a diameter or do they give us a radius? They give us a radius, so it'd be 2 pi r. Well, in our case, our r is 11. Okay, so setting up our equation, it'd be S equals 90 over 360 times 2 pi r, 2 pi 11. Okay, because our radius is given to be 11. Well, again, reducing this down, we're talking about a fourth of the circle. We're talking about a fourth of that circumference, times 2 times 11 is 22 pi. Then we'd have 1/4 times 22 pi. We can multiply that in our calculator. 22 divided by 4 gives us 5.5. So the arc length would be 5.5 times pi, which plugging that into your calculator, 5.5 times second or shift pi, going out to 2 decimal places, would be 17.28 meters. Okay, so that's how we can find the arc length of any given of any given sector of the circle that we're looking at. And so what they come up with here, that pattern, is then we can take the central angle, whatever that central angle is, over 360 times the circumference of the entire circle, and this will always give us the arc length. Okay, so this is the equation we want to use when we're looking for arc length. Okay, take the central angle divided by 360, multiplied by the circumference of the entire circle, and that would give us the arc length that we're looking for. Okay. Now, the other thing we can look at is, instead of just looking for the arc length, if we want to find the perimeter of the whole figure, in a circle's case, the perimeter of the whole circle would be the circumference, but sometimes if we're looking at a sector, we have to keep in mind when we're looking for arc length, that's just the curvature. That's just the curvature. That doesn't include these two pieces, so we have to add those back in. Okay, well, we've already kind of talked about how to find circumference from a circle, but let's look at one of these examples and then we'll look at the next. The circumference of a circle is its perimeter, and we have two equations for it. In our case, they're giving us the radius. So if they give us a radius, we're going to use 2 pi r. So our circumference would be 2 pi times the radius, which is 9. Multiplying that together, we get 18 pi. 2 times 9 is 18. And then our calculator, if we multiply that out, we get approximately 56.55 centimeters. Okay, so that would be the perimeter of this circle, which we would call the circumference of the circle. Okay, now if we're looking at the perimeter of something more like this, again, like I said, keep in mind when we find the arc length, we're only finding this piece. So we have to take that, what we find for the arc length, and add in the other two pieces to find the total perimeter. Okay, so let's find the perimeter of this guy. First of all, remember, we need to find this arc length. Okay, to find this arc length. So to find this arc length, it'd be S equals our central angle divided by 360 times the circumference. Okay, well, in our case, it'd be 135 is our central angle over 360 times the circumference. Well, the circumference here, they give us a radius, so we're going to use 2 pi r, and the r here is 15. Okay, so now we just need to simplify things out. We could simplify the fraction in our calculator, okay, and that comes out to be about 3/8, okay, and then multiply that to 2 pi r. Well, if we just multiply our 2 and 15, that'd be 30 pi. Okay, then we can multiply this guy together and we'd have 3/8 times 30, and again we can kind of multiply that in our calculator. 3/8 times 30 comes out to be 11.25 pi. Okay, so, and I get the same thing as they do. So our arc length here is 11.25 pi, But that's just the arc length. To find the actual perimeter then, the perimeter of the whole figure here, that would be 11.25 pi plus this length, okay? Because remember, perimeter is along the boundary line of the entire figure, plus this length, plus this length. Well, both of those are the radius of the circle, and both of those are 15 miles. Okay, so we're going to add in plus 15 plus 15. Okay, now first of all, we need to multiply out 11.25 times our pi in our calculator, which comes out to be about 35.34, and then we're going to add 15 and 15. Okay, plus 15, plus 15. So that comes out to be about what they get there, 65.34 miles. Okay, so remember, when we're wanting to find the perimeter, not just the arc length, but the perimeter, we have to add back in these two pieces here. Okay, all right, we'll cover the rest of these examples in class.